So let's continue practicing with these generic types, because I know they can be strange to wrap your head around. In the end, they're really straightforward though. Let's create another generic function, count and print. Now this function should take some argument, some parameter, let's name it element, but the name is really up to you, which should be of a generic type, because I really don't care about the type, at least in certain ways. So let's say we have one generic type in this function, and our parameter is of that type. And that's, by the way, also typical for generic types. If you have a generic function, then often your parameter will be of that type. Doesn't have to be, but often that is how you work with generic functions, as you will see as you get more and more experience with them. So here we got count and print with our generic type here, and the element is of that type. Now what I want to return here is in the end a tuple with two elements, where the first element should be my element itself, and the second element should be a description string. Maybe we name it count and describe, therefore. So here I got my description text, and here I'll say got no value. And I want to use that if we pass in an element which has no length, because my idea with count and describe is that we can pass in an array or a string, and we get back the amount of characters or elements in that string or array. So if we got an empty string or empty array, I want to use got no value. But here if I check that element.length is greater than 0, then I want to set description text to got plus element.length plus elements. We could be even more specific and check if the length is equal to 1 here, and then say got one element, else if element length is greater than 1, we have description text equal got plus element length elements, so that we got the plural form right. Now here, description text is therefore the second element I return here. Now you already see TypeScript complains about the length here, because it's not clear that element has a length. So maybe we should make it clear that it does. We could do so by creating a new interface or a custom type with the type keyword here, but here I'll go for an interface, which I'll name lengthy, which in the end is just guaranteeing that we have an object with a length property, which should yield a number in the end. And then here we can set a constraint and say that t extends lengthy. So we know whatever we get will have a length property, and an array or a string would have a length property. Now here I can console log count and describe and pass in, let's say, hi there. Now this works because a string has a length property. It's not an object, it's a string, but behind the scenes JavaScript kind of converts this to an object on the fly, you could say, and adds a length property when we need it. So therefore we can safely call it like this. TypeScript infers that here we return an array with either a string or type t elements in there. Now I want to have a tuple, so I'll be more specific here and set the return type to be basically an array with exactly two elements, where the first element will be of type t and the second element will be of type string. So now I'm just saying that we return a tuple here, where the first element will be, well, any element of our generic type, and the second element will be a string. Now with that, if we save this recompiles without errors and prints hi there, got 9 elements, because we got 9 characters in there. We could also call this with an array, where we have sports and cooking, and now you will see that we got 2 elements as a description text. Or also with an empty array, of course, in which case, if I save that, we got no value. But we won't be able to call this, for example, with a number, because a number doesn't have a length property, and therefore this does not work. So here again, we got our generic function. Idea is similar to the function before. We want to be a bit unspecific about the type of data we get here. We don't really care if it's a string, if it's an array, or anything else which has a length property. We just care about that it does have a a length property. And then we want to do something with it because we rely on the length property in our code. So we need to guarantee that we get that. But other than that, we really have no interest in which type of data we're getting here. I don't want to lock this down to a string or to an array, and I don't want to create a bunch of overloads to handle all the different possible types. I also don't want to create a very long union type here, because I might forget types which have a length property, or if I create my own object with a length property, I might not allow for it if I restrict this here to be of type string and array or anything like that. So therefore, I want to be more flexible, and with generic types we can be that. We don't care about the exact type. Here, thanks to the constraint, I only care about the fact that it has a length property.